Today we're going to be talking about forces in motion and friction. So before we get started, let's take a look at a short video.
Resulted. This is what Oh gosh. Oh,
Mike? You alright, pal? No, you're not.
So I want you to think about what are some forces that help you to walk. If you thought friction, then you would be correct. In class, we had a volunteer, and the volunteer ripped the runway. And as the volunteer was walking, we're noticing that this person walks. When they walk, they exert a backward force on the ground, and a reaction force moves them forward. Some surfaces are harder to walk on than others. Think about reasons why. Um, Less friction will make it a lot slippery. More friction will make it a little bit more difficult, like a gravel ground. An icy ground would be less friction, and that would be difficult as well. Think about different surfaces and how they affect your ability to walk. Now you have papers that look like this. We're going to be doing 14 words. Do not pay attention to the 7 pages because that's not necessarily true unless you're printing them offline. You will need 7 pages for front and back because they're not front and back. So again, if you're printing them offline, you're going to need to print 7 pages. If you're watching it and you already have the copies, then you should have 3 front and back copies and 1 half sheet that's front and back. As we go through, you're going to go ahead and write your words. So the first word is force. I want you to write it here in the top space where it says word, and then also write it down here in the bottom. Write the word force. As we go through, information is going to pop up and you're going to go ahead and copy it. If you need to pause the video, you do so. But I'm going to be moving kind of quickly, so if you have to rewind or pause the video, then do that. At the end of this, you will be drawing illustrations of each word, but let's go through the words and definition first. The definition of force is push or pull. The next word we're going to come to, it involves a gentleman by the name of Sir Isaac Newton. Think about the things you know about Mr. Newton. He was the discoverer of gravity. He was a mathematician. He also was a physicist where he studied motion, and he came up with some laws. The Newton's first law of motion states an object is at rest and stays at rest, and an object in motion stays in motion unless acted upon by an outside unbalanced force. This is also known as the law of inertia. This is an example of Newton's first law of motion. Notice the object is moving, but it's stopped because of an unbalanced force. Now what you're going to do is you're going to draw a picture showing the Newton's first law of motion. The next word is motion. Motion is movement. And again, if I'm going too fast, you have the ability to pause the video. Next, we have friction. Make sure you're writing the words down here in this space also for every single one, because when I put your books together, these may get a little cut off. and I want to make sure you're still able to see the word. Friction is rubbing together of objects or surfaces, and it causes objects to slow down. Inertia. Definition of inertia is objects staying in motion or at rest unless an outside force interferes. Notice that also sounds like Newton's first law of motion, which is also called the law of inertia. You have balanced forces. The definition is when two opposite forces are at equilibrium. We have equilibrium, and that just means equal. You have unbalanced forces, and that's when one force is greater than the other force and causes a change in opposite position. This would be like the tug of war. Now, in a tug of war, if neither side is winning, then that would be balanced forces. Or if two people were playing arm wrestle and neither side was winning, that would be balanced force. However, in tug of war, if one side won, then that would be unbalanced. If one in arm wrestling, if one side won, that would be unbalanced. Make sure you're writing the word down here. Acceleration. Acceleration is speeding up. Newton's second law of motion states acceleration of an object depends on force and mass. Speeding up of an object depends on force and mass. Force, remember, if you look at your word that we just did, it's push or pull. And then mass. Which object would hit the ground faster if we dropped them out of the window? A brick or a feather? If you said brick, you are correct because it has more mass, and the gravitational pull, which is the force, is stronger on the brick. Then we have Newton's third law of motion, and that's for every action there is an equal or opposite reaction. So, for instance, if we take a look at this video here, this is a rocket going up, up, and away. And what's that demonstrating is the action is the force pushing back on the ground and the ground pushing against the force out of the back of the rocket and the rocket reacting by going forward. Energy. That's the ability to work. We have potential energy, which is energy that is stored in an object. Then there's kinetic energy, and this is energy that is in motion. Now, for the slides, I want to make sure that you understand that you are to be drawing the pictures on each slide. I want you to draw the pictures down here. For every one of your definition cards, you should be drawing pictures. You have to do some thinking. Think of a picture that represents this word. So energy that is stored in an object, think of like a football. Football has stored energy. And everyone, you're going to be drawing a picture. You'll paper clip these pages together, and if you're not in class, you'll bring them to class with you when you come so that we can put them in your binder. I'm sorry, not your binder, your notebook. And this does conclude the end of this lesson. So you now need to take the time and go through each one and draw a picture.